At the beginning of the study of thermodynamics, I said that thermodynamics will allow us to know if a reaction will happen or it will not happen. What I meant exactly was whether a reaction will be spontaneous or non-spontaneous. Almost all exothermic reactions are spontaneous, but not all. Similarly, almost all endothermic reactions are non-spontaneous, but again, not all. There are certain exothermic reactions which are non-spontaneous, and there are certain endothermic reactions which are spontaneous. So, there is another factor apart from delta H, enthalpy, which governs whether a reaction is spontaneous or not. Delta H tells us whether a reaction is exothermic or endothermic. If the sign is negative, we say it's exothermic. If the sign of delta H is positive, we say it's endothermic. But the another factor is called entropy. Entropy is a measure of the randomness of our system. Now there is the other law of thermodynamics called the second law of thermodynamics, which says that the universe spontaneously tends toward increasing disorder or randomness. And so the universe is spontaneously moving in the direction of greater randomness and greater disorder. The higher the disorder or the higher the randomness, we say the higher the entropy. High entropy means highly disordered system. Example would be where we lack some regular repeating pattern. Think about holding a bunch of marbles in your hands and throwing them in the air. When they come down and hit the ground, they don't just stay together, they go in all the directions. They are not regularly staying together, cluttered together, rather they just disorganize themselves everywhere. Similarly, when we say that the universe spontaneously tends toward increasing disorder, think about your own room. If you don't fix it for a month, can you expect to walk in there and find everything in all its place? Even if you are not there for a month, gone out for a vacation, when you come back, you might need to clean some things up just to remove the dust. So, in the universe as a whole moves towards greater degree of randomness. There is no such thing as negative entropy, by the way. There is such a thing as negative enthalpy when the reaction is exothermic, but entropy is only given positive values, and higher entropy means more randomness, lower entropy means lower randomness. So let's understand entropy in greater detail. Here we got helium gas and solid sodium. Which of these two has greater entropy? If you said helium, you are right. Greater entropy means greater randomness. Now, in a gas, the particles are moving about very far away from each other according to the kinetic molecular theory of gases. In a solid, they are neatly arranged, crystalline, and next to each other in a regular repeating pattern. Hence, you have less disorder. So, sodium solid is going to have less disorder, lower entropy than helium gas, which has higher entropy. What about just the same substance but different states, liquid water and gaseous water vapor? So gaseous water vapor would have higher entropy because gas state means more disorder, more unorganized way all the molecules are moving about. For a reaction, similar to how we find delta H, we find delta S. We subtract the enthalpy, the entropy of the reactants from the entropy of the products. And when we take delta S, that's when the sign can be positive or negative. Okay? So delta S, if it is positive, means there was an increase in the disorder from the reaction. When the reaction took place and it formed products, the reactants turned into products, and if delta S was positive, that means there was greater disorder now in the product state than in the original reactant state. But if the delta S is negative, that means there was a decrease in the disorder. Here are some examples of when there is increase in disorder: solid turning into liquid, liquid turning into water vapor, like we saw for liquid water turning into water vapor, Then even mixing, when you have a pure substance like the one in purple, in which you introduce some solute like sodium chloride for example, eventually they mix together and they dissolve into each other. Now it's more disordered. They are not neatly separated from one away from the other in their own crystalline form, but they have mixed into each other. That's dissolution. And all of these three are examples of greater disorder happening. And so positive delta S. Now, when will a reaction be spontaneous and non-spontaneous? You have to look at both the enthalpy and the entropy. If a reaction is exothermic and if it results in increase in disorder because the sign of delta S is positive, then the reaction will always be spontaneous. Always. On the other hand, if the reaction, the delta H is endothermic and it also results in decrease in disorder, meaning the sign of delta S is negative, then the reaction is always non-spontaneous. It will never happen. And then there are the situations between these two where the reaction may be exothermic while the sign of the delta S could be negative, meaning that while it's exothermic there is a decrease in entropy, or the reaction could be endothermic while there is increase in entropy. So those combinations, you have to look at the relative sizes of each of these two components, and depending on that the reaction can be spontaneous or non-spontaneous. Here is another example of increase in disorder. If you have this two-chambered glassware in which you have this stopcock that stops the flow of gas from one side to the other, and if you open it, what happens? What exactly is spontaneity? You don't have to do anything except open the stopcock and all the gas that's in here will start to flow out, and eventually at some point both sides will have equal amounts of it. This is diffusion, and you know this by just logic, by your understanding of how the world works, that if you have this situation you will never arrive at this situation on the left from the right to the left by itself. You actually have to supply energy and cause all the gas molecules to move from here to one side. You have to either push them out or suck them in through pulling them in through some sort of mechanical instrumentation. But if you do have it in this state, it will turn into this state. That is a definition of what spontaneity is. And so this shows how disorder of the universe always increases. In this case, heat is not involved, just delta S is involved, and the universe tends to the side of increasing disorder. This is what happens. So the equation that takes delta H and delta S together is known as the free energy equation, here given to us as free energy delta G equals delta H minus T delta S. T here stands for temperature in Kelvin. Delta H is the change in enthalpy, whether the reaction is exothermic or endothermic, and delta S is the change in entropy, whether there is greater disorder through the reaction or less disorder. Whenever you apply this equation, you will get a sign of some value, some number. If the sign is negative, that means the reaction is always spontaneous. If it is positive, the reaction is always non-spontaneous. It's never spontaneous. Okay, so that is called free energy. And if we just look at the signs without looking at the numbers, if delta H is positive and delta S is negative, delta G will always be positive regardless of the temperature involved. So in the equation we have the temperature here, but if this is always positive and this is always negative, negative times negative makes it positive, and delta G will always be positive, meaning the reaction will never be spontaneous. If the delta H is always negative, it's for a given reaction it should be negative, and if the delta S is positive, delta G will always be negative, and regardless of what temperature you carry out the reaction at, the reaction will be always spontaneous because delta G is always negative. But if delta H is positive, meaning it's endothermic, and delta S is positive, meaning that the sign of the change in entropy is positive, then the sign of delta G will depend on the temperature. So if you have an endothermic reaction that increases the disorder, well, depends on the temperature at which you carry out the reaction. So let's have a look at this. If delta H is positive, meaning it's endothermic, we are counting on delta S to make the reaction spontaneous. But delta S is also a fixed value for a given reaction. If we carry out the reaction at a high temperature, that's when the reaction can become spontaneous, because that's when this term will become more negative. A positive delta S times a negative T makes it negative. So higher the temperature, this term will become larger. This tells us how entropy depends ultimately on temperature. If you have a situation where a reaction is not spontaneous at low temperature, it can be spontaneous at high temperature. If the enthalpy is positive, if it's an endothermic reaction, and if the change in entropy is also positive, meaning that it is increasing the disorder of the reaction. And finally, you could have delta H negative, meaning it's an exothermic reaction, and delta S also negative, meaning that it lowers the disorder of the system. Such a reaction would benefit if we carry out the reaction at a low temperature, because at a low temperature, the fact that there is a decrease in entropy, decrease in disorder, will have a smaller impact overall, while the delta H will not be affected by the temperature. So certain reactions, if we carry out if they are non-spontaneous at high temperatures, they can be spontaneous at low temperatures, depending on the signs of this. So it would be very helpful if you were to go through this and memorize each of these situations. Delta H plus, delta S minus, always spontaneous. Always non-spontaneous. Delta H plus and delta S minus, always non-spontaneous, because delta G is always positive. Delta H minus and delta S plus, always spontaneous, because delta G is negative. And this situation where both are plus, the reaction would benefit if you want the reaction to be spontaneous, carried out at a high temperature. If both are negative and you want the reaction to be spontaneous, carried out at low temperature. However, if the reaction has delta H plus and delta S minus, doesn't matter what temperature you carry it out at, it will never become spontaneous. And in this case, if delta H is minus and delta S is plus, doesn't matter again what reaction you carried out at, what temperature you carried out at, because the reaction will always be spontaneous.